HIT140 Group project presentation. Darwin Group 62.
Good afternoon, everyone. Today we are going to take you through a fascinating study that looks at the foraging behavior of Egyptian fruit bats, and in a particular, like how this behavior changes when black rats are present. So, when it comes to the central question, we want to answer this question: do bats perceive rats as predators or competitors? And if they do, how does that affect the way they forage? Throughout this presentation, we'll walk you through the background of this study, the data used, and the methods applied. We'll also go into detail about the results we found, including recognition models that help us analyze risk taking and delay behavior. By the end, you'll see how the environmental pressures and species interactions can shape decision making in animals. So when it comes to like background, to give you some context, bats are nocturnal animals, and their survival often depends on their ability to balance the need for food with the risk of danger. In this case, the Egyptian fruit bats are sharing their environment with black rats, which are not only competitors for food, but also they can perceived as potential threats. So likewise, we can think about this like you walk in through a cafeteria, but you see someone you know always fights for food sitting at the table. You might hesitate, like you change your approach or even decide not to eat at the table. So, likewise, bats in a similar way make constant choices when competition or risk is present. So, this study is really about how these bats access danger, whether it's predator risk or competition pressure, and how they avoid or adapt to it. By this, understanding this help us see not just individual behavior but also bigger ecological dynamics.
Thank you, Sherina. So now I will be speaking about the datasets that we used. Two primary datasets were used in this study. Dataset 1 focuses on bat behavior when they land on a food platform, and dataset 2 focuses on rat activity on the platform. We have a total of 907 bat observations and 12 variables, and 2123 rat observations with 7 variables. This data helps us understand the dynamics between the two species. Now I will be moving to the dataset approach. The analysis we conducted was mainly descriptive, meaning we focused on summarizing the patterns in the data. We looked at how bats behave differently when rats are present, compared to when they are absent, and analyzed seasonal effects on bat behavior.
Thank you, Achinta. So when it comes to the descriptive findings, in our descriptive findings, we observed that bats displayed more risk avoidance behaviors when rats were present, especially when the rats were on the food platform. Additionally, bats were more successful at foraging when rats were absent. We also found seasonal variations in bat behavior, where they were more cautious during the winter months and more vigilant when rat presence increased in the spring. Moving into the next slide, we're going to talk about the inferential statistics. We applied the Spearman correlation test to investigate the relationship between the delay in bat approach and the time since rat arrival. The result showed a weak yet statistically significant positive correlation. This suggests that bats may delay their approach if rats have been present for a while. Furthermore, the Man-Whitney U test revealed a significant increase in bat approach delay after rat arrival, showing avoidance behavior. Next, Ashita can explain about the logistic regression.
Thank you, Anjana. So for the logistic regression model, we predicted the risk-taking behavior of bats. We considered factors like the time since rat arrival, the time of the day, and the season. Our findings showed that bats were more likely to take risks when they arrive soon after rats. Additionally, we found that bats were more inclined to take risks during the winter season.
Thanks, Asindh. So, talking about OLS regression. For the OLS regression, we predicted that batch approach delay based on factors such as rat presence, the time of day, and rat arrival numbers. Although we have a low R squared value, we found that seasonality was the only significant predictor, with winter being associated with a slightly longer approach delay. This suggests that other factors such as the weather or bat health might be influencing behavior as well.
So, to summarize our results, we confirmed that bats avoid foraging when rats are present, and that their behavior is influenced by both rat presence and seasonal factors. However, our models didn't explain much of the variation in bat behavior, suggesting that more variables like bat health or environmental factors could be at play. When it comes to the limitations, our study has several limitations that must be considered. The sample size was relatively small, which may affect the generalizability of our findings. Additionally, the models had low explanatory power, indicating that they didn't account for all relevant factors. We also faced issues with manual annotations, which could have led to labeling errors that influenced our results. So Nathan can
So,
explain
coming up
about.
with the conclusion and findings. In conclusion, this study reveals that exhibit risk avoidance behavior in presence of rats, and that environmental factors like seasonality influence their programming decisions. Despite some limitations in our data and model fit, the findings provide valuable insights into the predictive prey dynamics of bats and rats. Future studies could look into the influencing factors such as weather, bat health, and larger sample sizes to enhance our understanding of these behaviors.
So that brings us to the end of our presentation. I hope this gave us you a clear understanding of the topic and some points to think about further. Thank you.